Meissner effect. Consider a normal conducting material. When it is placed in an external magnetic field, the flux lines are penetrated through the material. Thereby, the magnetic flux density is not equal to 0 when the temperature of the material is maintained above the critical temperature and the magnetic field of the material is maintained above the critical magnetic field. When the same material, if the temperature is reduced to less than critical temperature, less than or equal to critical temperature, and the magnetic field of the material is made equal to or less than the critical magnetic field of this particular material, then the magnetic flux lines will be ejected out of the material. Thereby, the magnetic flux density of the same material becomes 0. Thus, it behaves as a superconductor. So, this is the property possessed by the superconducting material when the temperature and the critical magnetic field is less than or equal to its critical value. This property of the superconductor is similar to that of a diamagnetic material. This effect is said to be Meissner effect because this was first observed by the scientist Meissner. Proof for this effect is magnetic flux density B is equal to mu naught into M plus H or I plus H. Mu naught is the permeability of free space. I or M is said to be intensity of magnetization. H is the applied magnetic field. Now, for a superconductor, from the second diagram, it is evident that B is equal to 0, but mu naught has a value 4 pi into 10 power minus 7 Henry by meter. Therefore, B becomes 0. 0 is equal to mu naught into I plus H. Therefore, I plus H is equal to 0. I is equal to minus H or I by H is equal to minus 1. The ratio of I by H is said to be the susceptibility. Since the susceptibility value of the superconducting material is minus 1, negative, this superconducting material behaves as a perfect diamagnet. Now, isotope effect. Isotope of superconductor is also a superconductor. The presence of isotopes slightly changes the transition temperature of the superconductor. Let us assume mercury. The atomic weight of isotopes of mercury ranges from 199.5 to 203.4 atomic mass unit. So, the range of the transition temperature or critical temperature is 4.185 Kelvin to 4.146 Kelvin. According to Maxwell, the transition temperature is inversely proportional to the square root of the atomic weight of the superconductor. If it is mercury, this is the value. The general value is Tc is inversely proportional to m power alpha. If alpha is equal to 0, there is no isotope effect. No isotope effect. Persistent current. A ring form of a superconductor is taken. It is kept in a magnetic field. It is kept in an external magnetic field. Thereby, current is induced in the material by electromagnetic induction. When the applied magnetic field is removed, even after the applied magnetic field is removed, the current persists in the ring because of the magnetic flux lines are trapped inside the ring. Because of the resistivity becomes zero, as well as it is a ring form of a superconductor.